Investigation 9, graphing functions. As we have seen, functions can be displayed as graphs on a coordinate plane. And so let's review what we've learned. To graph a function, we use a xy pair of numbers as coordinates of a point on the plane. And so to do that, we are going to graph this equation y equals 2x. And we've been given for x 0, 1, 2, and 3. And so as a reminder how to do this, remember that when we solve this, we're going to put 0 in for x right here. So we're going to go y equals 2 times 0. And 2 times 0 is 0, so y equals 0. And then we're going to go y equals 2 times 1, because now we're going to replace 1 in there instead. And so 2 times 1 is 2, so y equals 2. And then when we put 2 in, y equals 2 times 2, that's 4. So we just put 2 in for x, and now we're going to put 3 in for x. And so when we put y equals 2 times 3, that's 6. And so now we have some sets of ordered pairs. The first ordered pair is 0, 0. And we graph 0, 0. We don't go left or right. We don't go up or down. That's the origin. And so I'm going to put a point on 0, 0. And then we go to the next one, which is 1, 2. We go over 1 and up 2, from 0 over 1 and up 2, and put a point. And then we go over 2 and up 4. Again, always from the origin when we're doing this. Over 2 and up 4, and put a point. And then we're going to go over 3 and up 6, because our last point is 3, 6. So over 3 and up 6. And notice that this creates a line. And we're going to create that line here by drawing the line to continue through the points. And so we're going to also go backwards through the points. So it looks approximately like that. And so this is the equation of the line y equals 2x. And so a couple things you need to notice. It's going over 1 and up 2 between each one of these points. And notice this. It's going up 2, going up 1. Every time. From here to here, it's going up 2. Here to here, it's going up 1. So it's going over 1 and up 2 every time. And so that's this number right here. Really, this is 2 over 1. So it goes over 1 and up 2 every time. Now, what we're going to do with this then is look at these graphs of these equations. And so we extend the line through and beyond the points, because we graph all possible pairs of numbers. And so we don't end this right here. These aren't the only 4 ordered pairs. We could pick any number. We could pick 100. And so y equals 2 times 100, that would be 200. So out there somewhere on this graph, way up at the end of this line, is the ordered pair 100, 200. So we go over 100 and up 200. And so we could also do negatives. You could put in negative 10 in here. And so y equals 2 times negative 10. That would be negative 20. So we'd have negative 20 here, and so we'd have negative 10, negative 20. So there are a whole bunch of different ordered pairs for this particular line, not just these points that we were given. And that's important because we need to often be able to figure out other points on the line. We're going to talk about some special graphs today. And the special graphs have a relationship that we're going to talk about, where they start, if they end, or where they end, and what points they go through. So below here we have the relationship of the perimeter of a square with its side length. And we're going to look at the graph of this. So why does it has an arrow on one end but not on the other end? And so if we think about what this is, we have a perimeter of a square that has side length 1. Can we have a perimeter that doesn't have any side length? that's not possible because we can't have a perimeter if we don't have some side length here. So we start out really at 0, 0 here, because if we have 0 side length, we have 0 perimeter. And so this graph starts at 0, 0, and it continues over, and it's going up by 4, because there are 4 sides, and how do we find the perimeter? We add 4 sides together. So notice this, it's going up 4, it's going up 1. So it's going over 1 and up 4, over 1 and up 4, over 1 and up 4. And there are many graphs that look kind of like this. If you think about what it is they're doing, they're starting at 0, 0 because we can't have any negatives. Can you have a negative side length? We can't. So some graphs start at a certain point and then continue to go over and up, instead of going both directions. Notice that the x and y axis are renamed as s and p in this function, so we could replace this with an x and this with a y, but really it's the same thing. It's y equals 4x. Okay, so whether we use x and y or p and s, the one that's on that's being multiplied here is your x-axis, and then what you're getting out of that is your y-axis. So the graph of this function is a ray. What are the coordinates of the endpoint of the ray? So this endpoint, what is that? What coordinates are those right there? Well, those are 0, 0, because if we have no side length, we cannot have a perimeter. And so why is the graph of this function a ray and not a line? Because we can't have any negative side lengths. And we can't have any negative side lengths because you can't have a negative side length on any distance. There's no negative distance. Okay? It says, notice that the graph of the function p equals 4s is straight and not curved. And so these are all straight lines we're going to be talking about today. It says, imagine 2 squares in which the side lengths of the larger square are twice the side length of the smaller square. Draw the 2 squares and find the perimeter of each. What effect does doubling the side length of a square have on the perimeter? So let's do this. Draw 2 squares. So draw a square and pick a number. Let's just pick 2. And so we know all the squares here are, the sides are all 2. And we're going to double this now. So it says to double twice the length of the small square. So this is going to be twice. It's going to be 4, 4, 4, and 4. And so this one is 2 times 4. And this one is 4 times 4. And so this is 8, and this is 16. And so what do you notice about the two of those? Well, 8 times 2 is 16. So the perimeter on the second one is double the perimeter on the first one. So what effect does doubling the side length of a square have on the perimeter? It doubles the perimeter. So if you double the side length, then you double the perimeter. What do you suppose happens if you triple the side length? Then you will triple the perimeter. Okay, so that relationship is what we call proportional, because it stays the same no matter whether you double it, triple it, quadruple it, times each one of them by 10, you still get the same amount, doubling or tripling or quadrupling or timesing by 10 when you do the perimeter. Rates are functions that can be graphed. Many rates involve time as one of the variables, and speed, for example, is a function of distance and time. And so suppose Sam enters a walkathon and walks at a steady rate of 3 miles per hour. And so think about that. That's really 3 miles per 1 hour. And so for every hour he goes over, he goes up 3 miles. So if we look at the points for that, In 1 hour, he can walk 3 miles. In 2 hours, he can walk 6 miles. In 3 hours, he can walk 9 miles. Here's the graph of what that looks like. For every 1 hour he goes over, he goes up 3 miles. So we're talking about hours and miles. Notice they didn't just go 1, 2, 3, and 4. They put in some other numbers here. They put in fractions, so these are fourths on the bottom here. So he could walk a quarter of an hour, and he goes some distance. And in half an hour, he goes some distance. And in 3/4 of an hour, he goes some distance. So there are many pairs on this line, and they just drew this graph so that you could see some of them. And notice that they labeled both axes. They notice also that they adjusted the scale of the graph so that each tick mark on the horizontal scale represents 1/4 of an hour. So that's what I was just talking about. This is 1/4 of an hour. This is half of an hour. This is 3/4 of an hour that they're talking about there. Okay. So the functions that we've all been talking about just now are called direct variations. And direct variation is a relationship between two variables where as one changes, the other changes by some amount. And so if you look back at these problems, on this one, as we changed by hours, the time or the distance in miles went up. So we changed by 1 hour here, and the distance went up 3 miles. So each one of these is changing. Also notice this. It goes through 0, 0 again. And now, why are they starting at 0, 0? They're starting at 0, 0 because, again, you can't go negative time or negative distance. So if you don't have any time in hours, you haven't gone any distance. Okay, so these are starting at 0, 0. So direct variation is just showing that a relationship varies directly. In other words, if something changes, something else changes by the same amount every time. So things like Gina's paid by the hour. The more hours she works, the more she's paid. If she works fewer hours, her pay decreases. And so we call that directly proportional. And we can form a proportion with two pairs of numbers that follow the rule of the function. So if we were to look at these, side length and perimeter, we would look and see that, are these proportional? Well, is 3/12 the same as 5/20? And notice we're comparing the side length to the perimeter. So usually we set this up like this, and we have these pairs, 3/12 and 5/20. And so we need to look and see at the proportion for each of these and whether they're equal. So I'm putting the 3/12, and I'm putting the 5/20. And so looking to see if those are proportional. Well, 3/12 is 1/4, and 5/20 is 1/4, so they are proportional. So we can look at other examples of this. It says this table shows the number of dollars Gina earns working a given number of hours. Select two pairs of numbers from the table and use them to write a proportion. And then, are the cross products of the proportion equal? So they're doing cross products, but if we look at this, if we look at 1 to 5, is that the same as 2 to 10? Is that the same? Yes. And if we look at cross products, if we look at these are equal, we look at cross products, 5 times 2 equals 10 times 1. But we can look at this and say 5 times 2 is 10 and 1 times 2 is 2. So we can look at it two different ways by looking at the cross multiplication of that, or we can just look and see, are they proportional? There's an equation that goes with this. It's directly proportional things always have some constant, where you have y equals some constant times x. And if you remember, our perimeter equals 3s. 3 times the side length, or 4 times the side length. How about 4 times s? that fits that, because y is p, x is 5, and k is 4 then. So it changes every time by that constant. And we call that constant proportionality. And here it is down here as well. So 4 is the constant of proportionality. So let's look at a couple of these examples and see whether they are direct variations in proportional. The number of pounds of apples purchased and the cost. So if you purchase more apples, then they cost more. Time spent walking and distance. If you have some distance that you're walking, then it's going to, if you walk more distance, it's going to take you more time. So that constant is however fast you walk, and the constant on the first one is the actual cost of those apples, or how much each pound of apples costs. The graph of a function with direct variation is a straight line or ray or segment or line points that includes the origin. So there's two things that are very key right here in this statement. Straight line goes through the origin. So anytime you have something that's a straight line and it goes through the origin, it's going to be a direct variation or proportional. We also have some things that are inverse variation equations. So think about this. If you and a friend, actually if you could work mowing lawn, alone it would take you 6 hours. But if you and your friend mow the lawn, it's actually going to take less time. So that's directly inverse, basically, of what we've just been talking about. So what we've been talking about is if you have more time, it's going to go, or more, if you have more lawn to mow, then it's going to take you more time. But this is saying if you have more lawn to mow, that it's going to take you less time because there's more than one person doing it. So that's what inverse variation is talking about. And so inverse variation is a little bit simpler because if all you need to do is show the multiplication of what you're doing. If it takes 2 hours to go 60 miles an hour, then in 4 hours you can do it at 30 miles per hour. So the time really is remaining the same, and what's changing is the miles per hour. So here's a problem. It says find out how long it would take Adam to make a trip at 40 miles per hour. And so let's go back up to this problem up here. It says a trip takes Adam 2 hours traveling at 60 miles per hour. So 2 hours at 60 miles per hour. Then the trip would take twice as long, 4 hours, if he had traveled at half the speed. And so that's what we're talking about here when we say 2 hours at 60 miles per hour and then 4 hours at 30 miles per hour. So if he doubles his time, he halves how fast he's going to go so that those are still equal. And so in 2 hours he can make it at 60 miles per hour, but if he's going 40 miles per hour, then how long is it going to take him? And so we can solve this by dividing both sides by 40, solving simple equations, because we know that t times 40 is equal to 2 times 60. And so we can do some canceling here. I'm going to cancel the 10s, and I'm going to cancel a 2, and then 2. And so we end up with 3 times 40, because 3 times 40 is the same as 2 times 60. And so he can take 3 hours at 40 miles per hour and go the same distance he went if he went for 2 hours at 60 miles per hour. So what they're asking you to do here is make a function table to show that Adam's rate in miles per hour and his time in hours to make the 120-mile trip for these different speeds. So we already did the 40 mile per hour one. So we're going to write this out. 40 miles per hour, let's start with the 20. So 20, 30, 40, and 60. And so this is the miles per hour, and this other one is going to be the time that it takes. So at 20 miles per hour, so 2 times 60 equals 20 times t. We're going to divide both sides by 20. And we're going to get 6 hours. We already did this one up here for 40. That's going to be 3 hours. What about 30? So 2 times 60 equals 30t. Divide by 30. So that's 4 hours. And what do you suppose in 60 miles an hour? So 60t equals 60 times 2. Divide by 60. And so it takes 2 hours. Notice, as one goes up, the other goes down. And really that's what they're trying to get you to look at, is this one is getting bigger, but as we go down, this thing is actually getting smaller as we go down. And so it can't be directly proportional. And so let's look at directly proportional here. Is 20 over 6 the same as 30 over 4? Are those in the same ratio? Well, no, because 20 times 4 is 80, and 30 times 6 is 180. So they're not proportional. And so that means they're going to vary indirectly here. Most of the time, work problems are inverse variation. Because if you have more people doing the same job, it's going to take you less time to do it. So one is going up and the other is going down. So Raffi and one friend can roof the whole house in 24 hours. How many would it take Raffi and 2 friends to roof the whole house? So we know that if he has him and himself and 1 friend, it's going to take 24. But if we add 1 more friend, it's going to take less than 24 hours to do this. So work problems are often involve person hours or person days, how much time it takes one person working 1 hour. And you can estimate the number of person hours of labor, and we multiply the number of people working times the number of hours they work. So here's an example of that. We have person hours of 2 people doing it in 24 hours and 3 people doing it in we don't know how many hours it takes them. So this is, again, a simple equation where we need to just solve the equation. And so what are we going to do? We're going to divide both sides by 3. And so when we do that, 3 goes into 24, 8, and 8 times 2 is 16 hours. So 3 people can do it in 16 hours, where 2 people could only do it in 24 hours. Solve the following work problem by writing and solving an equation that shows 2 products are equal. 3 people can do it in 8 days. How many people can do it? In 2 days. Oops. So 3 people can do it in 8 days. How many people can do it in 2 days? And so we need to know what we can do to solve this. So there's our x. We don't know how many days or how many people it's going to take. So we're going to divide by the 2 days. And so we get 12. So 12 people can do this in 2 days. Quick multiplying mentally problem. We can use this to help us multiply mentally, because if we have inverse variation, then we can decrease one of these factors and increase the other proportionally, and this will give us something easier to multiply. So think about this. If I take half of 24, that's 12, and I double, so I'm dividing this one by 2 and I'm doubling this one. What happens to those 2 2's? That's the same thing as canceling those 2's. That's 12 times 30. And do you know what 12 times 30 is? I do. 12 times 3 is 36, with a 0 is 360. but I don't know what 24 times 15 is. I would have to get out a calculator to do that problem. So basically what they're doing is they're taking 24 times 15 and they're timesing it by 2 over 2 and choosing what to cancel and what to multiply. So they canceled this 2 with the 24 and got 12 and multiplied 2 times 15 here, and so 12 times 30. Okay, and this is just a quick thing to help you mentally do these problems if you don't have a calculator. So product of 25 and 18. I don't know the product of 25 and 18, but I bet I could find the product of 50 and 9. So I'm going to double this one, and I'm going to divide this one by 2. 50 times 9 then is 5 times 9 is 45. So 450. So again, this is just a quick way to use this inverse variation to help us mentally multiply. So inverse variation, as one variable changes, the other changes inversely. So if one is going up, the other is going down, and by the same amounts. 0 is not a solution for either variable. In other words, it doesn't go through 0, 0. And so if you think about what we just talked about with the direct variation, it does go through 0, 0, and it's a straight line. When we do inverse variation, it doesn't go through 0, 0, and it's not a straight line. And the products of the numbers pairs that satisfy the function are equal to each other. So this is where we talk about 25 times 18 being equal to 50 times 9. Or if we look back up here in this other problem, how we figured out that 3 times 8 is equal to how many people times 2 days. Okay, so we're using that rule that they're equal to each other because they're inversely related.